The beginning of the search for ET. During the early 1960s, the beginnings of SETI in Green Bank were very humble. Project Ozma, named after the Wizard of Oz, was the first project to search for extraterrestrial signals. A 26-meter radio telescope was used, and pulsed signals were searched for on a narrow band of frequencies at a wavelength of 21 centimeters. The radiation of the atom, hydrogen, since Giuseppe Cocconi and Philip Morrison published an article in Nature in 1959 entitled Searching for Interstellar Communications, in which they suggested this very frequency for searching for extraterrestrial signals. The first stars to be studied were the two sun-like stars Epsilon Eridani and Tau Ceti. Only one radio channel could be monitored, while modern technology, on the other hand, allows millions of channels to be checked simultaneously. Nevertheless, the famous astronomer and book author Carl Sagan was fascinated by the idea. He was one of the first to point out that our sun is still relatively young and that extraterrestrial civilizations could be millions or billions of years ahead of us. This would open up unimagined technical possibilities for them, but at the same time, it does make it seem less likely that such a highly advanced intelligence would communicate with radio waves. Further, they could also heavily scramble their signals to save energy or remain undetected. In the early 1970s, Bernard Oliver, vice president of Hewlett-Packard, joined the discussion and proposed another frequency, the emission line of the hydroxyl group, which consists of one hydrogen and one oxygen atom. Today, this range is also called the water hole. So SETI had to struggle with a number of problems. For one thing, we don't know in which frequency range an extraterrestrial civilization would transmit. So the SETI project focuses on the frequency range between 1 and 3 GHz, the range between 30 and 10 centimeters of wavelength, close to the 21 centimeter wavelength of hydrogen, 1.42 GHz. However, this implies the assumption that aliens think similarly to us. Furthermore, every material object also emits electromagnetic radiation, whose radiation maximum is at a frequency determined by the absolute temperature of the object. In addition, there is periodic radiation of pulsars or the tremendous radiation of gamma-ray bursts, GRBs, that emits radiantly like a lighthouse. In other words, there is a tremendous noise in the universe, and this greatly limits our ability to communicate or detect an extraterrestrial signal. In addition, although radio waves propagate in a straight line in a vacuum, the interstellar medium is enriched with gas and dust particles and filled with quasi-stationary magnetic fields, which disturbs radio waves by absorbing, reflecting, or diffracting them. This leads to fluctuations in signal strength and/or a phase shift, which can cause the waves to amplify, but also to cancel. But SETI has to fight not only with technical difficulties, but with political ones above all. Because on more than one occasion, the financing of SETI was overturned by the US Congress. For example, in 1972, when it was decided that the National Science Foundation, NSF, could no longer support this project. Therefore, SETI is now run as a donation-funded, non-profit organization to be independent of the political squabbles. The first supporters were William Hewlett and David Packard, as well as Gordon Moore, co-founder of Intel, and Paul Allen, co-founder of Microsoft, who was also very generous with the Allen Telescope Array named after him. This current project will no longer rely on the existing structure of radio telescopes, but will instead use new 356.1 meter radio telescopes from scratch, designed specifically for SETI's needs. Wow signal, or how to recognize extraterrestrial contact attempts. In 1977, more precisely on August the 15th at 23:16 local time, the so-called WOW signal was discovered with the Big Ear radio telescope of the Ohio State University within the framework of the SETI project. This annotation WOW by astrophysicist Jerry Emmons is in red paint next to the character code 6EQUJ5 on a signal printout. The signal intensity was given in numbers from 1 to 9, and after 9 in letters from A to Z, with Z representing the strongest intensity. The signal was 30 times stronger than the background noise, making it very intense. It was also very narrowband. It appeared on only one of the 50 monitored channels, whereas natural signals from neutron stars, quasars, etc. are broadband. It was close to the radio emission of neutral hydrogen, HI line, and it was received for 72 seconds. In a rigid telescope like the Big Ear Radio Telescope scanning the sky, one expects a signal to peak after 36 seconds and decay thereafter because of Earth's rotation. So it met many of the criteria one would expect from an artificial extraterrestrial signal. Despite intensive investigations, the nature of the signal could not be clarified until today. And this, although the most abstruse sources of error were indicated and the sky region from which the signal came from the proximity of the 3-star systems of the Chi Sagittarii in the constellation Sagittarius, was monitored since then several times. However, the WOW signal was recorded only once and could not be confirmed by another source. Pioneer plaques. The Pioneer 10 probe was launched in March 1972, and its main mission was to explore the planet Jupiter and gather knowledge about the outer region of our solar system. The probe has since left and was the first man-made object to become an interstellar space probe. In case this probe encounters an extraterrestrial civilization in the coming millennia, there is, just like on its sister probe Pioneer 11, a plaque on board. This shows the hyperfine transition of neutral hydrogen, a man and a woman in an Adam costume, the relative position of the Sun in comparison with 14 periodic pulsars to the center of the Milky Way, as well as the position of Earth in our solar system. Voyager Golden Records, Sound of Earths. We've already made a video about the very successful Voyager 2 mission. On both the Voyager 1 and Voyager 2 probes, there is a golden record with pictures and sounds of the different cultures and the diversity of life on Earth. Like the 2 Pioneer probes, the 2 Voyager probes have also left our solar system and are traveling through the interstellar medium. The Arecibo message. The Arecibo message is an interstellar radio message carrying basic information about humanity and Earth that was sent in September 1974 to globular star cluster M13, about 25,000 light-years from Earth. The message was transmitted with a wavelength of 12.6 centimeters, which corresponds to a frequency of 2,381 MHz. The signal had a duration of 169 seconds and consisted of 1,679 bits. Similar to the Pioneer plaque and the records of the 2 Voyager probes, the scientists created a template for this short message on which the location of the solar system was drawn, but this time in digital form, consisting of ones and zeros. In addition, the broadcast included a drawing of a human figure and some chemical formulas that are particularly important for life on Earth. The content of the Arecibo message was designed by Frank Drake, then at Cornell University and creator of the Drake equation, who wrote the message with help from Carl Sagan and others. Because of the huge distances, however, an answer from space can be expected in 50,000 years at the earliest. Breakthrough Listen. Currently, the so-called Breakthrough Listen program is searching for extraterrestrial communication using the Green Bank Telescope and Parkes Observatory. The project began in January 2016 and is supported by Jeff Marcy and the now sadly deceased astrophysicist Stephen Hawking, among others. This is the most sophisticated search for ET to date, as more than 1 million stars are to be intercepted, and the project will run until at least 2026. In December 2020, an interesting signal, the so-called Breakthrough Listen Candidate 1, BLC-1, was intercepted from Proxima Centauri, but so far, it cannot be ruled out that the signal has a human origin. Life-friendly molecules are common in the universe. As announced in mid-September 2021, the MAPS program has used ALMA to study 5 protoplanetary disks for the presence of life building blocks, such as cyanoacetylines, HC3N, acetonitriles, CH3CN, and cyclopropynidynes, CC3H2. As a result, significant reservoirs of large organic molecules were found in 4 of the forming solar systems. Moreover, the data shows that this planet and comet-building material is chemically similar to our own solar system. Accordingly, there may be much more extraterrestrial life than previously suspected. Thank you for your attention. If you like this video, give us a like or leave a comment.